Hello again. Welcome to another lesson in geometry. Today we're covering section 6.5, conditions for rhombuses, rectangles, and squares. So just like when we studied parallelograms, we then went back and said, well, first we said, what are all the things that make a parallelogram? What happens? And then we went backwards and said, given these things, we have a parallelogram. Well, in section 6-4, we figured out what makes something be a rhombus, a rectangle, or a square. And in this section, we're going to go backwards. We have these things. That's what makes it become a rhombus, a rectangle, or a square. All right, so first we have a little vocabulary review. A quadrilateral is a polygon with 4 sides. Crossed out the figure below that is not a quadrilateral. Well, that one has 4 sides, that one has 4 sides, and that one has 4 sides. So this pentagon does not. Vocabulary builder number 2, diagonal. A definition for this, a diagonal is a segment with 2 endpoints at 2 non-adjacent vertices of a polygon. Okay, so a diagonal goes from one across to the other, one across to the other. Now, if you have a pentagon, each vertice has 2 diagonals. Okay. All right, so the word's origin, the word diagonal comes from the Greek word dia, which means through, and gonio, which means angle. So a through angle or a corner angle. Okay. Circle the polygon that has no diagonal. It's going to be a triangle. Okay. Triangle has 3 sides, and if I try to go through it to another one, I just end up on the same side, one of the sides. So circle the polygon that has 2 diagonals. That's going to be a quadrilateral. We've seen lots of those. Okay. Draw diagonals from one vertex to in each figure. So draw all the diagonals. So for a pentagon here, we have 1, 2 diagonals from each vertex. For a hexagon, we have 1, 2, 3 diagonals from each vertex. And for I don't know how many sides that has. We have 1, 2, 3, 4. So that was a hexagon. No, not a hexagon, heptagon. So write the number of diagonals you drew in each of the figures above. So a pentagon had 2 diagonals. Hexagon had 3 diagonals, and a heptagon had 4 diagonals from one vertex. Okay. So notice a quadrilateral really has 1 diagonal from a vertex. Okay. And then a triangle has no diagonals from each vertex. All right, let's flip it over. And we have a whole list of theorems here again. So theorem 6-16, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So if we have perpendicular diagonals, and we learned last time if we have a rhombus, then the diagonals are perpendicular. And this time we're going in reverse. We're saying if the diagonals are perpendicular, then we have a rhombus. Okay. And 6-17, if one diagonal of a parallelogram bisects a pair of opposite angles, then we have a rhombus too. So we learned in last unit that if we have a rhombus, by the way, a square is a rhombus, right? One diagonal splits these into equal parts and those into equal parts, then we have a rhombus. Okay. So a rhombus goes in reverse now. If we have that diagonal splitting them, we have a rhombus. Or if it was a rhombus, the diagonal split them. Okay. So insert a right angle symbol in the parallelogram at the right to illustrate theorem 6-16. So the right angle is going to be where these two cross, the diagonals cross. And then insert congruent marks to illustrate 6-17. If one diagonal of a parallelogram bisects a pair of opposite angles, then it is a rhombus. So let's put our congruence ones in here. So this is going to be 3 and 4 are the same, and 1 and 2 are the same as each other and as 3 and 4. Okay. All right, use the diagram from exercise 7 to complete exercise 8 and 9. If ABCD is a parallelogram, then AC is perpendicular to BD, and then ABCD is a rhombus. So if we have diagonals that are perpendicular, we got a rhombus. All right, and then if ABCD is a parallelogram, and angle 1 is the same as angle 2, and angle 3 is the same as angle 4, then we have a rhombus. Okay? If a diagonal splits it into two congruent pairs, then we have a rhombus. Okay? By the way, 1, 2, 3, and 4 are also all going to be congruent to each other. So theorem 6-18, another theorem here. 1, 2, 3. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay? So if they're congruent diagonals, we have a rectangle. We learned last time if it's a rectangle, the diagonals are congruent. So this is just the converse. Okay? So insert congruent marks in the right angle symbols in the parallelogram to illustrate the 6-18. So if the diagonals are congruent, then we have a rectangle. So our right angles go in the corners here, because that's what makes it be a rectangle. And we should have congruent marks on this diagonal and this diagonal. Now it's hard to show those diagonals because remember the diagonal goes all the way across, okay? And then this one goes all the way across. So the blue one and the green one are congruent to each other. Okay? Use a diagram from exercise 10 to complete the statement. If ABC is a parallelogram and BD is congruent to AC, then ABCD is a triangle. No, not a triangle, a rectangle, sorry. Okay. Circle the parallelogram that has diagonals that are both perpendicular and congruent. So we want diagonals that are perpendicular, so that means it must have right angles. It's going to be something like that. And we want then to be congruent. Oh, that means it has to be a rhombus. So it has to have all the sides the same. So the only kind of quadrilateral that has right angles and all the sides the same is going to be a square. Okay, on problem 1, we have identifying special parallelograms. And we have a got it here. So our got it says a parallelogram has angle measures of 20, 160, 20, and 160. Can you conclude that it is a rhombus, a rectangle, or a square? So I can mark out rhombus, a rectangle, and square right away because the angles aren't 90, so we're good with that one. So can we conclude that it might be a rhombus? So let's take a look. So it says draw a parallelogram in the box below, label the angles with their measures, and use a protractor to help you make accurate angle measurements. So here is mine that I went ahead and drew ahead of time. And if we look on here, we can see that this guy is about 160, okay? I'm sorry, that's not 160, that's 20. So there's the 20, okay? And then if I move it over here, we can see 160, okay? So it's going to be each, okay? So in here is going to be a 20, and here's going to be 160, and then that's a 20, and that's a 160. So we have the right angles. Underline the correct word or words to complete each sentence. You do or do not know the lengths of the sides of the parallelogram. We don't really know. We got to make them ourselves. Okay, so we certainly can't conclude just by drawing the right angles what the lengths of the sides would be. Okay, you do or do you not know the lengths of the diagonals? Well, I don't know what the lengths of the diagonals are. Okay, the angles of a rectangle are all right angles. The angles of a square are all right angles. This is why we can mark out square and rectangle right away. Can you conclude that the parallelogram is a rectangle, a rhombus, or a square? And it's going to be no. All sides are not equal. Necessarily equal. So we don't know about rhombus. And no angles are 90, so not going to be a square or a rectangle. So it could have been a rhombus if we had drawn it special, made all the sides the same, but it's certainly not going to be a rectangle or a square. All right. Problem number 2, using properties of special parallelograms. So for what value of y is quadrilateral DEFG going to be a rectangle? So for what value of y will that have to work? So if DEFG is a parallelogram, then the diagonals must bisect each other. So that makes it a parallelogram. So I know that like this length should be cut in half, and this one should be cut in half. Okay. So in this case, EG is going to be equal to 2 times 5y plus 3. And DF should be equal to 2 times 7y minus 5, because those opposite parts of the diagonal should be the same. Okay? And then we can simplify that to 10y plus 6 and 14y minus 10. So for quadrilateral DEFG to be a rectangle, the diagonals of the rectangle must be congruent. Now write an equation and solve for y. So since the diagonals must be the same and we know the lengths of the diagonals, one diagonal is 10y plus 6 and the other diagonal is 14y minus 10, we can solve for y here. So we're going to get 6 equals 4y minus 10. And then we're going to add 10 to both sides. We're going to get 16 as 4y. So that means that y is going to have to be 4 for this to be a rectangle. So if y was 4, then the diagonals would be the same length, okay? Which would both be, in this case, 46. Okay, on problem 3. This is a got it problem. So do we got using properties of parallelograms down? So suppose you are on the volunteer building team at the right. So you're one of these 4 people, and you're trying to make a square play area. So you want to create a play area that's square. How can you use the properties of diagonals to help locate the 4 corners? So notice all these people are stretching out some ropes here, and we want to use our ropes to help us find the 4 corners. So you could cut 2 pieces of rope that will be diagonals for the square play area, and you want to cut them to the same length because a parallelogram is a rectangle if the diagonals are congruent. So if we have a rectangle, then this diagonal, the blue, should be congruent to this one. So if we cut our blue and red ropes to the same length, then those will be our diagonals for our square play area. Okay, so this will guarantee us right angles. All right, so you can join the 2 pieces of a rope at midpoints because a quadrilateral is a parallelogram. We got to make sure it becomes a parallelogram. If the diagonals bisect each other. So to do that, we would just loop them around like this, and where they meet, tie them up. Okay? So now we have midpoints. All right? You move the diagonals so they are perpendicular because a parallelogram is a rhombus if the diagonals are perpendicular bisectors of each other. Okay? So we're going to do this. There's our blue one now. Oops. Okay. And here's our red one. And there's where they tied together in the middle, midpoint still. So we know these are congruent and these are congruent. And that the blue and red one are all congruent to each other too. So when we're done, we're going to end up with right angles in here is what we were supposed to do. And we should have a square. Okay? So explain why the polygon is a square when you pull the ropes taut. So you pull the ropes out, and let's see, we can write all the stuff out. So congruent diagonals bisect each other. So we made our diagonals be congruent, and we made them bisect each other. Okay. So you formed a rectangle. Okay, remember a rectangle is a parallelogram with diagonals that are congruent. So we forced it to be a parallelogram by tying them at the midpoints, and we forced it to be a rectangle by making the diagonals congruent. Okay, so that gets us there. And since the diagonals are perpendicular, so since the diagonals are perpendicular, you formed a rhombus. That's the rule for rhombuses. The diagonals have to be perpendicular. And a rectangle that is a rhombus is a square. And that goes back to our Venn diagram. Okay, so if it's in both, it's both a rectangle and it's a rhombus, then it has to be a square. All right, we have our lesson check. As always, pause the video, do the lesson check yourself, and then come back and check over your solutions. All right, so welcome back. Name all of the special parallelograms that have each property. So property number 1, the diagonals are perpendicular. Okay, well, that's not going to work for a rectangle. That only works if all of the sides are the same. So this is going to work for a rhombus and a square. Okay. Property 2, or B here, diagonals are congruent. Diagonals are going to be congruent only for if we have right angles in the corners. So rectangle and a square only. So for a rhombus that doesn't have right angles, not going to work for us. Okay. All right. The diagonals are angle bisectors. So the diagonals bisect the angles. Well, that doesn't work for a rectangle. That only works if all the sides are the same. So we're going to do rhombus and a square here. Okay. Diagonals bisect each other. Now, if they bisect each other, we get all of the shapes. That works for a rectangle, that works for a rhombus, and that works for a square. They bisect each other, so the diagonals cut each other in half. Okay. All right, so diagonals are perpendicular bisectors of each other. That only works for a rhombus and a square. Perpendicular are going to work on a rectangle. So a rectangle has congruent bisectors, congruent diagonals, but they don't bisect each other to form perpendicular. Okay. All right. So check off the vocabulary words that you understand. In this case, we should be getting pretty close to really understanding a rhombus and a rectangle and a square, and definitely diagonal. We've been working with that one for a while. And then where are you on using the properties of parallelograms, these special parallelograms? All right, I will see you in class next time, and then we'll try to organize all this stuff into one big thing to help us study with before our tests coming up. All right, see you in class.